Namaste, good day to all my students. In this lecture, I will explain Module 5 backward approach. Using this approach, we are solving different problems. One problem is N-Queen's problem. First, before going to this problem, what is meant by this approach I will explain. For that, I took one example here. Based upon this one, I am going to explain. See, there is a source and there is a destination. A person want to go to destination, from source to destination. That is the problem. Now, how that particular person can solve this problem? First, the person is standing here. He want to move. There are two paths. One is this path and one is this path. He is going to take, assume that he is going to take this particular path. He will come here. From here, the path is splitting into again 3. He may go to this particular path. Once it is going here, he is getting to know that there is no further path. He will go back to this particular area. From there, again he is going to try for this particular path. Again he is getting to know that this path is going to end here. He will come back here. Again he will try this one. From there, again he will come back. That's why backward approach. Backward approach means he will go to one path and he is not getting the solution. He is going to getting to know. Then he will come back here. Right? Here he tried all the possibility. Then he will come back again to the source. Again he is going to backward approach. He will come back to here. Here again he has seen that this is already I tried. I will try with this one. He will go here. And from here the path is again splitting into 2 divisions. He will try the first division. Again he will come to backward direction. That is why backward approach. From here again he will go and he is reaching the destination. What you have to understand here is, based upon the programming, maybe we will go to one place, there it is some splitting may be there. We will try all the ways of path, or we will try for different types of solution. But if you are not getting, we will come back. Again, we will see the next path. There also we are going to try. In one way, we are going to get the solution, right? That is called as backward approach. Backward approach means we will try and we will come back and we will try again. That is the backward approach. I hope it's clear with backward approach. This N-Queen's problem is going to solve using backward approach, right? It's very simple. I will explain what is now N-Queens. Now, what is N? N can be any number. Based upon this, what it is there is based upon 4. 4 queens. 4 queens means we have to construct a 4 cross 4 matrix. You see here, it is a 4 cross 4 matrix. 1, 2, 3, 4. 4 columns. 1, 2, 3, 4. 4 rows. It's a 4 cross 4 matrix. If it is given as 3 queens problem, then we have to construct a 3 cross 3 matrix. If it is asking for 2 queens problem, we have to construct a 2 cross 2 matrix, and so on. Now I will explain the 4 cross 4 matrix explanation for 4 queens problem. Right. Now you can see here there is 0. Why it is 0? That is the starting position. Now what is N-Queen's problem? I will explain now. For N-Queen's problem, there are 3 rules are there. That 3 rules are very important. In the examination, if they are asking, first you have to highlight that 3 points or 3 rules. What are the rules? I am going to explain, right? The first rule. How to keep the queens? That is a question here. Before going for the rules, I will explain one more thing here. The thing here is we have to keep the queens here. You can see here, queens. And we have to keep the queens in 4 cross 4 matrix. Now the rule is how you should keep that particular queens. The first rule, we can keep 1 queen on 1 row. If I am keeping 1 queen here, I can't keep any queen in next 1, 2, 3 places. Because in this particular row, I already kept 1 queen. That is the first rule. I will repeat the rule. We can keep one queen on one row. I hope it's clear. That is why here we kept one queen. We cannot able to keep the other queen in the same row. Next one, row is over. Next, the rule for the column. We cannot keep the queen in same column. That means if I kept one queen here, anyway this row I can't keep. I have to go to the next row, second row. First row it's end, second row. Second row, can I keep the queen here? No. Why? Because we cannot keep the queen in same column. Then if it is coming here, it will come in the same column. It is not possible. That is the next one. I hope it's clear. Next, the third rule is we can't keep the queen diagonally also. That means anyway I can't keep the queen here. I am trying here. If I am trying to keep it here, then it is diagonally it is coming. So that particular queen I can't keep here also. That is why three rules. We can keep one queen on one row, maximum one row, one queen only we can keep. The second rule, we cannot keep the queen in same column, and third rule, we cannot keep the queen diagonally. Right. Now I am going to explain how it is solved. Right. First, 4 cross 4 based upon the question you have to draw. Yes, 0. We are not trying, or we are not trying to keep the queen anywhere. First one we are trying to keep. First, can I keep the queen here in the first location? Yes. Why? We do not want to worry about these 3 rows because that is the first row. We can keep one queen there. There is no question at all. We can keep. Now, next I am trying for here. Can I keep it here? No, because it is a column problem. That is why it is showing as 1 cross. 1 cross means first column I can't keep for the second row. That is the meaning here. Can I keep it here? No. Why? It is going to get diagonal problem. That is why 2 cross. Can I keep it here? Yes. Column problem is not there. Row problem is there, not there, because in this row only one queen will come. Diagonal also is not there. That is why in the second number you can see here queen is kept here. I hope it's clear. Now third row we are trying, because already I told first rule itself is 1 row, 1 queen. That 2 rows we feel, third row I am trying. Can I keep it here? No. That is why 1 cross due to the column. Can I keep it here? No, due to this diagonal. This diagonal is the problem. That's why 2 cross. Can I keep it here? No. Why? The column problem. Can I keep it here? No, due to the diagonal. That is why 1, 2, 3, 4. It is not possible. It is like here. All the possibilities I tried here, it is not possible. Or first possibility I tried, it's not possible. I will try for the next possibility. Next possibility I will try. It is backtracking. Now I cannot able to fill in this row. Why? Due to this queen. Now I should backtrack. That means I should go back to this particular row. And can I keep this queen, move the queen from this location to here? Any problem? No, because there is column problem won't come, diagonal problem won't come. That is why in the same line or row, we are drawing this particular one, because this queen we are moving from this location to this. Now I am again trying here. Can I keep here? No. Column here? Yes. I done it here. I hope it's clear. Now again I am trying here. Once I done, there itself we have to try. That is why this cross it is showing for the next what I am going to explain. Can I do it here? No. 1 cross. Can I do it here? No. Both are column problem. Can I keep it here? No. Again it is diagonal problem. Can I keep it here? No. Due to the column problem. Now I kept the queen here. That is why I am not able to do anything. Can I move this queen from this location to here? That is the next one. No, because diagonal problem. Can I keep it here? No. Again column problem. Then it will come out. That means now this one I can't move due to this one. Again I should go here, this row. Anyway, there is no way, because it is in the last column it is sitting. I should throw this one outside, then there is no way. Now this is also wrong. Then again I should backtrack to the first one. This location what I kept initially queen here, it is wrong. That means this queen I should move to the next location. That's why we have to go back to the first. In the same line we have to draw the 5, because This queen, what we kept it here, it is wrong. I kept it here now, queen, fifth one. Now I am trying for the next row. Can I keep it here? No. Column. Diagonal problem. Can I keep it second? No. It is column problem. Can I keep it here? Again, diagonal problem. Can I keep it here? Yes, it is possible for me. Why? Because diagonal or column problem is not coming. Anyway, row problem won't come. That is the first Q. That is why sixth it is showing as Q is here. Next, I am trying for 7. Can I keep it here? Yes, that's no problem. Column or row problem is not coming. That's why 7th figure it is coming like that. Now, can I keep it here? No. Which problem? Column problem. Can I keep it here? No. It is diagonal problem. Can I keep it here? Yes, I can keep it here. That is why the queen is like this. This is a solution I should write here. But while is the examination also, you should show this is a solution. Now, one more solution is there. That how to do is, this queen, you can place it here. Right? Based upon that one more solution you are going to get. This queen, just to move here, then try it. You will get one more solution. That one you have to do it as homework. I hope it's clear with n queens problem. Next, I am going to explain the algorithm for n queens. This is the algorithm for n queens. Before explaining this algorithm, I will explain something about this solution. Please clearly understand it. This was the solution we got it previously. First queen is here, second is here, third is sitting here, and fourth is sitting here. Based upon this particular algorithm, I returned this one. How it is written, I will explain. This X is the solution array. X of 1, this one is showing the row number. X of 1 equal to 2. That means first row, second column, first queen is going to sit. I will show you. First row, second column, first queen is going to sit. See here, x2, 2 is the row number. And this side what we are going to write is the column number. This number, the queen is going to sit. X2, second row where the queen is going to sit, fourth column. I hope it's clear. Next, X3, third row where the queen is going to sit, first column. Correct. X4, fourth row where the queen is going to sit, third column. I hope it's clear how it is going to write. This one, if you are understood, this is very easy. Now, see here, there are two functions or there are two algorithms are there. One is place, one is n queen. Place, it is showing this particular part, it is helping. Can we keep the queen in that particular place or not? See here. In this case, second row, I will take the example. Can I keep the queen here? It's possible. That particular question it is going to do by here. That means the place where we can keep the queen, it is going to get it from this particular algorithm. If I am going to keep it here, it's not possible due to the diagonal. Diagonal it is going to violate. I will explain. If it is keeping here, column is going to violate. If it is keeping here, again diagonal is going to violate. That is finding with the help of this particular algorithm. Okay. Now this particular algorithm is going to take the input. Now I will explain here. The two parameters are there for this particular function n queen, k and n. What is k? K is the row number, right? K is the row number. N is the total number of queens. How many queens are there? 4 queens. K value is the row number, right? See here, I is equal to 1 to n. Normally k value first it will come as 1. There is no doubt. While it is passing the parameter, k value initially will be 1. 1 and 4. I hope it's clear. I is equal to 1 to n. This particular for loop is for the columns. This particular for loop is for the columns. Now, place. Place means it is going to call this algorithm place k comma I. K is first row, first column. Can I place or not? Because ki value is 1. What is the k value? Already I told it is 1. 1 comma 1, can I place it or not? That is a question. Then it will come to this particular one. It is possible to place 1 comma 1. Initially we placed it, right? Then it is going to execute here. This one I will explain in the second iteration so that it will be clear for you. Now again I will go here. I will explain some more things here. See here, inside here, x of 1 equal to 1. This particular one only. This one only I already explained, that only it is here. X of 1 equal to 1. Right. That means this particular single dimensional array is going to fill. X of 1 is equal to 1. That is wrong because we have to get as x of 1 is equal to 2. Next. Okay, it will set. Initially it will set x of 1 is equal to 1. Then it will try. What is the use of this? If k is equal to n. What is k? It is a raw number. K is equal to n. What is n? Total number of queens. It is 4. That means k value first it will be 1. Next k value will be 2. Next k value will be, first k value will be 1. Next to 2. Next to 3. Next to 4. What is the meaning? If you reach to 4, you are filled all the queens perfectly. That means you can go for printing. That is the meaning. K is equal to n means 4 is equal to 4. Then you can write it. How to write? With the help of k array. That means this value it's going to print. How it will print? X of 1 is equal to 2, x of 2 is equal to 4, x of 3 is equal to 1, and x of 4 is equal to 3. That is going to print. If k is not reached to fourth row, that maybe k may be in the first row or k may be in the second row. Then, for example, k is in the first row. Next, we have to fill the second row. How to do it? N queens of k plus 1. Why it is k plus 1? I already told that k is the row number. First row is filled. Next row we have to move. At that time, it have to do as k plus 1. N value won't change. Always n is 4 only. I hope it's clear this particular part. Now, I will take the example of this particular second row so that you will understand the place also. See here, k value is 2. Why? Second row I am going to explain here. I value is 1. Initially, again it will be 1. Now, here it is k is 2 and I is 1. Now, it is loop is going to execute. What is k value is 2, right? Now, j is 1 to k minus 1. It is 1. Why j will execute only up to 1? Why? Because is if I am filling this particular row, I only have to worry about its previous row. I do not want to worry its below row because I am not filled. If I am filling this row, I should worry about this particular row where the queen is kept. Based upon that one, column will come or row violation will come or not, I should check. That is why it is k minus 1. If I am filling on the third row, it only have to fill up to k value is 3. That means I am going to fill the third row. Then I should only see first row and second row. That is why k minus 1 value will come as 2. I hope it's clear. Now, there are two conditions it is getting to check here. It is or. One is this condition. This condition is going to check it is as that particular queen will come in the same column or not. That is the use of this one, right? And this particular condition is the absolute value. ABS is the absolute value. Negative value is coming. You have to make it as positive. That's the meaning of that. And this particular condition is going to check it will come on diagonally or not. That is why this is same column or not, and this is going to check diagonally or not. If any one of the condition is satisfying, it will say that false. False means you cannot able to keep that queen on that particular place. I will explain based upon this value. First queen will come here because I value will be 1 here, right? I'm trying here. Can I keep the queen here? No. Which one it is going to violate here? Diagonal. That means this condition is going to satisfy. This won't satisfy. Why? Because it is a column condition. This is going to satisfy and it will return false. Again, it will go there, right? And it is going to call again. It will come here. At that time, the I value is going to change to 2. K value will be same. I value will be 2. That means this one I can't. I am trying for this one. At that time, what will happen? This particular condition is going to satisfy. Why? This is the column condition. This is going to satisfy, right? At that time, false. Due to false, again it will go here. Again, the I value will be increment to 3. Then it will come here. It will come here, and again this particular place is going to execute. That time, this particular condition is going to satisfy. Why? This is for diagonal. If I am keeping here diagonal, it is going to satisfy. That means this one won't satisfy, this is going to satisfy. Again false, right? Again I value will be increment to 4, fourth column. K value will be same. Here it will come. Here what it is going to happen? Here the column also won't satisfy, as well as diagonal also won't satisfy. Then it will return as true. What is the meaning? We can keep it here. Like that, each row it is going to execute. I hope it is clear with my explanation. Thank you very much.